Hello friends, welcome back to Java 9 modules tutorials. In the previous session, we have seen how to create a module, how to create a module descriptor, how to compile and execute a code which involves Java module programming. Now, in this session, we are going to see two important keywords, requires and exports, and how to use them in Java main modules and what are their features, what are their functionalities, etc. Apart from this requires and exports, we have a lot more keywords used in Java 9, but these two are very important things which we are going to see now. We will see the functionality of rest of the keywords in forthcoming video sessions. For this session, we are going to restrict our scope up to requires and exports. What is requires and what is exports? These keywords are. Okay, let us take requires keyword for now. Right. So where we use these particular keywords, we are supposed to use these keywords in our module descriptor file. Our module descriptor is nothing but module-info.java. There we define our module. So inside the descriptor, we may define the requires or exports keywords for some special purpose needs. Okay, so let us take the first keyword requires and its significance. What is the need for the requires keyword? In other words, what is the functionality requires offers to us? It is very much similar to the import statement we used to provide in packages. For example, what do we do? If we need some code in Java, we used to write import java.util.star, import java.io.star, import java.sql.star, right? So what does it mean? It means the code I am writing now is dependent on some external packages. I need to import that package in my code. So the import statement is nothing but to resolve dependencies on external packages. Similar to this, I'm having a module. My module may have some dependency with some external modules. I need to import. I need to resolve a dependency with an external module. For that, I need to use the keyword requires in my module descriptor. So the JVM, while compiling my code, it understands my module descriptor and it creates an internal dependency with that particular external module using the keyword requires, and it compiles the external module beforehand and make it available for us to execute our code, that is our module. That means we are defining the compiler, my code, my module is having an external module dependency with this particular module. That is what the keyword requires tries to explain. For example, I have a module X which may have some dependency on module Y. What it implies is module X requires module Y. This is how the requires keyword comes into picture. Right. This is what the main scenario where requires keyword is needed. Now, as I told before, inside the jmods folder, we have some handful of modules created and available for us to use. There is one particular module which is the parent for all the modules. I have told that detail in the previous video. So that particular module is java.base. We have many modules available in Java 9, but java.base is the parent module which never has any dependencies. This java.base is a standalone module. All the modules of Java 9, either they may be Java as a specification modules or JDK modules or even the user defined modules you are going to write, everything is dependent on java.base. That means there is a dependency on any module you are going to write which is with java.base module. So we need to specify requires java.base, but Java 9 ecosystem, Java 9 virtual machine will never mandate you to require java.base in your code, because since this java.base is a parent for all the modules, implicitly Java 9 has that specification on requiring java.base to your modules. So if even though your module is more dependent on java.base module, there is no need for you to specify requires java.base explicitly in your module descriptor, because Java 9 runtime environment will take care of this for this particular module. But if you are having another modules or user defined modules you are writing, they may have some internal dependencies between some other modules, not with java.base. Some other modules you might write requires explicitly in your module descriptor. So that is the difference between using requiring java.base and other modules. There is no harm if you still require java.base from your module descriptor, but it is not a necessary thing because internally JRE of Java 9 will take care of this particular thing. Right. So now let us get into the picture. I am opening the command prompt, maximizing the screen. Here, what we are going to do is home. In my runtime folder, I have JDK9, inside which what I'm going to do, I'm going to invoke Java. There is one flag we are going to see today is describe module. So this is going to describe the module we have in Java 9. Which module I'm going to see now? I am going to see some details about java.sql. Let us see what happens. So this is the list. See, java.sql is the module which I am interested with. What the compiler is telling, java.sql 9 is the module name. It has 3 export statements and 3 require statements. What does it mean? It has 3 require statements. That means in order to compile and use this java.sql module, we need these 3 modules should be already available. The requires may have 3 to 2. There are various types of requires. Now here they have mentioned mandated and transitive, which we are going to see in future sessions. But for now, we are very much interested only with the keyword requires. What package? Java.base. It is an implicit thing, no need to mention it. Apart from this, it has some dependencies with 2 other packages, 2 other modules, java.xml and java.logging. So what does this particular statement specifies is this module java.sql has some dependencies with java.xml and java.logging, of course with java.base. So this is how a module expresses. The module tries to convey that these are all the dependency modules needs to be prepared beforehand. Okay, so let us see how to use this particular requires in our code. What is the role of requires keyword in our general day-to-day Java programming development? Let us see that in the video. Yeah, now I am switching over to my Java 9 samples folder. Okay, this folder is empty. Now what I am going to do, I am going to create a simple module. It is very much similar to this what we did in yesterday. We are just going to repeat it and I will try to explain some good things now. So it is nothing, no harm in repeating the stuff. So while I am repeating the stuff, definitely it will add more value to you to learn modules easily and faster. Right. Now what I'm going to do, I'm going to create a folder, my module. So here pico my module-info.java. So I'm going to create a very simple module info module my module. That's it. It is a very basic module descriptor. Now I am going to create some folders for my package. My module com mm, my package pico my module com my package, going to name the file as hello.java. So package com.mypackage public class hello public static void main string of args println hello from module. So I am done with the code. Now I am going to compile the code jdk9 bin java c is this one my module info my module com my package hello.java. So I am done with compilation of the code. Now I need to execute the code. So what I am going to do, java hyphen hyphen module hyphen path. What is the module name? My module. This inside which I have module info.class and hyphen m So my module com.mypackage.hello. So what does this code says? It says hello from module. So this is what simple repetition of the class which I have written in the previous video tutorial. I have just repeated here. Now what I am going to do? I am going to add a requires dependency here. So what I am going to do here? What I am going to do here? I am just opening module info deployment descriptor, inside which I am going to add one particular statement requires. I already told java.base is the package which already being implicitly required by Java 9 virtual machine. But now I am just adding an explicit statement on java.base here. Requires java.base. I am trying to explain the compiler. My module is having a dependency with java.base module. So after saving this code, I am going to compile this. So there are no errors. Even if I try to run the code without errors, it is being executed. So no harm whether you are importing, whether you are requiring java.base or not in your code. There is not at all, it never matters you are importing, you are requiring it or not. Right. Now what I am going to do, I am opening my Java source code. Here I am very much interested to write some code using JDBC. So for that I have imported java.sql.star. So it is a very simple code which we are writing in JDBC. Now I am saving it. Now I am going to compile my code. See here, package java.sql is declared in module java.sql, but module my module does not read it. What does it means? It means java.sql is not available for the runtime environment to compile. What does it mean? Even up to the Java version, Java 8, even for the previous versions, Java 1, 2, 3, 4, up to the versions of Java 8, this java.sql is a package and it is available by default to the Java virtual machine or the Java runtime environment to compile it. But here, what is happening? This java.sql is now moved as a module. It is not a package anymore. That module is totally away from the current default runtime environment. So in order to use this particular module, we need to explicitly specify the module descriptor. There is a dependency with java.sql. It is the way we need to use the requires keyword here. So we are going to require java.sql in our module descriptor. So I am trying to open my module descriptor here. I am going to add requires java.sql. Now I am going to compile the code. It got compiled. So even though if I run the code, it will execute without any issues. But even we are not doing anything relevant to the SQL. But the thing very much important is the usage of requires keyword here. So we need to specify the Java compiler. My module is having a dependency with the module java.sql. So I need to require it explicitly in my code. So it is all about requiring a particular module from our module. So this is the importance of the requires keyword. Now we are going to see something which is very much interesting. What I am going to do, I am going to create two different modules. Here what we have seen, we have a requirement, we have a dependency with an existing Java module. Now what I am going to do is I am going to create two user defined modules. Will have some dependencies between each other. We are not going to see a dependency with an existing Java module. We are going to create user defined modules and we will enforce dependencies between these two modules. So how we are planning to organize this structure? How we are planning to organize this structure? So let us go like this. So we are going to create a multi-module application, an application with more than one modules. Here we have the module 1. We are going to have module 2. Two modules we are going to create. Module 1 will have a package called com.packageone. It will have a class wish. There will be a method called sayHello. So this is what our module 1 is going to be. We are also going to create one more module with the name module 2, with com.packagetwo as the package. Inside we are going to have a class GetWish. It is going to be a main class with main method. So what the thing is going to happen is this module 2 is going to have a dependency with module 1. So in the module 2 module descriptor, we need to specify a requires or a dependency of module 1. So this is what we are going to do now. Module 2 requires module 1. So this is how we are going to design an application. Let us see how it goes. I am going to open the command prompt. I am creating a folder for my multi-module application. It is a normal folder, mkdir multi-module, cd multi-module. So this is a new directory I have created for my operations. Now what I'm going to do, I'm going to create those two modules which are mentioned here. Module 1, module 2. mkdir module 1. Similarly, mkdir module 2. I am done with two directories. So what I'm going to do, I'm going to add module descriptor for both of them. So pico module 1 module-info.java, here module 1. It is an empty one. So I'm not going to add any of the requires or anything for now. I'm just creating them. Similarly for module 2. So both of them are empty module descriptors. Now pico -p, which folder, sorry, not pico, mkdir -p module 1. What I'm going to create, com package 1. Right? Yeah, I'm creating a directories. Similarly, for module 2, I'm creating a package 2. Now I'm going to write the code for module 1. So module 1 com package 1, what my class is going to be named as wish.java. So here package com.packageone imp, so class I'm going to write public class wish. Public string, what is the method I am going to write here? sayHello. This is what I'm going to do here. So return hello from module 1. So that's it. Saving the code. I am exiting now. So this is how I need to write my first module code. Now what I am going to do, I am going to write my second module, which is going to be before that I just want to compile my first module code as well, right? That is very much important for us. So how I am going to compile, I need to invoke my JDK9 runtime environment Java C. What is the code I need to compile? Module 1 slash module info, module 1 slash com.packageone.wish. What is the problem? Oh, okay. W should be capital, right? It is a small typo issue. I will fix it now. Uh, yep. So compiled the code. Now I'm going to create the module 2. So how I need to do? Pico module 2 com package 2. My class is going to be named as GetWish.java. So here I'm going to add package com.packagetwo, same public class GetWish, inside which public static void main string of args system.out.println. So here wish from module 2. So now we have created the structures for both of our modules. I'm going to compile them. So module 2 is ready now. Module 2 slash module info, module 2 slash com.packagetwo and GetWish. Done with the compilation. So I am able to compile both of these modules. But this point we need to note that we don't have any link between these two modules. Module 1 is having one package with a class and a method. Module 2 is also having one package and a main class with a main method. So we don't have any dependencies resolved or defined here at this particular point. Now what I am going to do is I'm going to specify something interesting here. What I'm going to do now, I am going to open package to GetWish.java. Here I am very much I am very much interested to import my module 1. So how to import module 1? com.packageone. This is what I am going to import to my code. This is what I am going to import to my code. So by adding this statement, what I am trying to say, I am going to import package 1 to my code. So what I am going to import from package 1, I am going to import the class wish. Wish is the class I am going to import from package 1. That package 1 is residing in module 1. It is a different module. So what I am trying to do with the wish equal to new wish of. Here I am trying to say system.out.println wish dot say hello. This is the method inside the wish class. So I'm trying to invoke it. Now I am saving the code and exiting. So what I need to do now, what I need to know now I am going to compile this code. It is inside the package 2. So I am trying to compile this code package 2 module 2, right? Yeah, correct. So if I try to compile this code, it is telling there is no such particular package named wish exists. We need to add that particular package to our code. Now we have the wish class, we have the com.packageone residing in module 1. So we need to require that module 1 in our module 2. Then only the wish will be available for us to import. So how to import it? So I am going to open my module descriptor. So what is my module descriptor? My module descriptor is pico module2 module-info.java. So what I need to do here, is I need to requires module 1. So this is my module 2. This module 2 requires module 1 as a dependency. This is what I am trying to say the Java compiler beforehand. Now I am trying to compile the code. See here, module not found, module 1. So what the compiler is complaining now is there is no module 1 exists. Okay. So one important thing now we have to do is we already have module 1. We have some package inside it. We have some code written inside a package with a method. Now what we are going to do from module 1 is we need to expose this particular package to public. By default, the scope of every package relies within this particular module. That means the scope of com.packageone relies only within module 1. The scope of com.packagetwo is restricted only up to module 2. So what does it mean? Here, the scope of packages inside a module will be restricted only within that module. So if you want to, in order to expose the packages inside a module to a public scope, we need to use exports keyword. So this is where the keyword exports comes into picture. So we know where this requires is coming in, because the requires is to resolve the dependency, identify the dependency and use it in our module. Whereas here this exports specifies this is the package we are going to export to public from this particular module. So in our case, in module 1, I need to mention com.packageone is the package which I am interested to expose to public. I mean com.packageone.wish is what I am interested to expose it to the public. So this is what I need to mention in my module 1. So even though I may not mention the class, I need to mention the package. That is very much important. So I need to mention this in my module 1 module descriptor. So now what I am going to do, I am going to specify exports in my module descriptor. So I'm going to open my module 1 here. Inside this module 1, I have a module descriptor. It is an empty thing. Here, what I am going to specify exports. What I am trying to export here, I am trying to export here com.package 1. So this is the package I am trying to export as a part of module 1. So wherever I require module 1, this com.packageone package will be available for them to use. So that means inside this package I have a public class which is wish. It is also will be available for that class which is requiring this particular package, this particular module. Done with the code. Now, in order to compile this, we have some special way to do in Java 9. We are not supposed to compile with the conventional way where we compile our regular modules we did just earlier. So if we compile it, it will definitely show an error. So what we need to do, we need to compile both the modules altogether. It is not like compiling module 1 separately, compiling module 2 separately, then you are running. I have just now cleared my console. Now what I am going to do, I am going to type ls. So it contains module 1 and module 2 which we have written so far. Now again we are going to compile this file using some dependency switch. So how to compile this file? The same way we did home, our softwares, jdk, 9 folder and then bin java c. The same way we invoke the java c compiler. Now, while invoking the Java C compiler, we need to mention something important here, which is module source path. This is an important flag we need to mention here. So where does our module source exists? Our module source exists in current directory. For that we need to mention a dot. It means the current folder contains all our module source path. And what are all the modules I am going to compile here? That is very much important. So the modules I am going to compile here are module 1 with the module-info.java, and similarly module 1 with com.packageone with the file name wish.java. Similarly module 2 with the module descriptor, and similarly module 2 with the package and the file inside this package. So we have mentioned the Java C compiler. This is the source path. I am collectively compiling both the modules. I am not compiling one by one. I am specifying my module source path is the current folder. Inside the current folder, I am need to compile module 1 module 1 descriptor and module 1 source code. Similarly, module 2 descriptor and module 2 source codes. Right. Now I am trying to compile this code, but still it is asking for no class output directory specified. Since we are doing a collective compilation of all the modules, the Java virtual machine the compiler expects an output folder to put out all the classes. Now I am not interested with any external explicit output folders. I want to put all the binaries in the same folders where their package and code exists. In order to make this, for the same command, I am going to include a flag -d. It stands for destination, where to put the binaries, where to put the class files. -d dot the same directory in which my module source codes available. So this will help me in compiling this code. So this code compiled both the modules. It identifies all the module dependencies. It identifies the requires and exports keywords. It identifies module 1 and it exports the package com.packageone residing inside the module 1. And while compiling module 2, it requires module 1, and while compiling the class GetWish.java, it imported the package com.packageone wish.java and compiles the code as it is. So this command above specified is very much important. The flag module source path is also very much equally important. We need to mention from where the source should be referenced. It is the current directory, so that I mentioned it as dot. And what are all the sources I need to include here? My module 1, the module descriptor, and the files related to module 1. Similarly, module 2, the module descriptor and files related to module 2. So all these files needs to be compiled collectively, and the binaries needs to be generated in the current folder only. Because we are creating and generating the binaries in the current directory, we are able to refer module source path in the same directory. So it is important to maintain the destination as current folder, so that the Java compiler will understand the source code is also residing in the current folder using the dot operator. Right, now we are done with compiling our code. Now I am very much interested to execute and see the response in action. So how to execute? It is the same way how we did earlier. So the same way how we did it earlier. Home, the same softwares, jdk 9 slash bin java. This is what I am going to execute. So where is my module path resides here? Module path. Here I'm not going to specify any particular module. My module path is dot. That means the current directory in which all my class files generated. Now which one I am going to execute? I am going to execute my module 2 now, because module 2 is having its main class. So what I am going to execute here? com.packagetwo.getWish. This is my class. So I am trying to execute this class. See here, hello from module 1, wish from module 2. So the module 1, the package inside module 1 com.packageone is imported, and the class hello is class wish is also being imported there. So let us open the code and see what exactly is happening. So pico module 2 module 2 getWish.java, you can see here. So what we are doing here, importing the package 1.wish class, we are instantiating wish, and using the object we are invoking the name sayHello. So what are we doing in the wish class? That is exactly printed here. So if I open the source code of wish, it is inside the module 1. We are printing the word hello from module 1. So that is how the package is getting compiled, hello from module 1 and wish from module 2. So both of them are taking place. So this is the way how we need to import a package from an external module. So in the external module we need to write exports. That is the keyword, very much important to expose a module to public. And also in our another module we need to have a dependency resolved using the requires keyword. So this is the relationship between exports and requires. If I want to expose some of the packages from my module, I need to expose it using the word exports. If I want to use external modules from my code, I need to use the requires keyword in my module descriptor. So this is all about requires and exports while dealing with Java 9 modules. We are going to see some more details on the requires and exports and other keywords in module development in the forthcoming video sessions. This is an exhaustive video having lot more information to grab. Please go through this thing slowly, and each and every line is very much important while writing the code. So keep more time, allocate some more time to learn this module session which deals with requires and exports. If you have any doubts, please put them in the comment section. I am very much happy to answer your doubts, queries, and even if you have any suggestions of improvement, whatever you wish that suits, please put it in the comment section. Please click the subscribe button and don't forget to click the bell button. This will enable you to get an update whenever a video gets posted in the YouTube channel. Thanks for watching. Let us catch up in the next video session, which will be some more detail. Apart from the requires and exports, we are going to see some more keywords, how to handle modules more efficiently. Thank you for now.